Hello, everyone. Welcome to this session for Oracle Transaction Manager for Microservices. We are going to provide an overview. And my name is Deepak Goyal. I'm part of Oracle Database Product Development Team. Along with me, I have Todd Little, who is architect for this product, and Brijesh Dev, who is leading the development for the product. So as the agenda is concerned, we are going to talk about microservices, application development trends, and what are the challenges associated with this, then Oracle's strategy. Todd is going to go over the architecture of this product, what functionality, features that we are providing, and Brijesh has a demo to show this product in action. And in the end, I'm going to go over the roadmap and upcoming features. So starting with the microservices applications, just to give you a background, monolithic application, we all know these are one big application, they are local transaction, there is one database which is being updated, a lot of dependencies among each other, all these modules. There could be millions of lines of code and several thousands of tables and so on. It's everyone is familiar with what the challenges are in these kind of monolithic applications. We go to the microservices-based applications. There are smaller modules. These are independent units that can be developed, tested, and deployed independently. They are talking to a database on the back end, and that makes it easier to maintain and so on. But there are some challenges also associated with microservices application that because there are so many microservices, now there is orchestration complexity. How do you make sure that these services are talking to each other in a proper way? And now you have to manage the multiple data stores. And of course, there's greater latency because of the REST API. All these services are talking to each other using over the network rather than in-process communication. So some of the challenges actually continuing with that because we are microservices are very scalable application. They are independent units. You can keep on adding to those microservices. But what we are doing here is we are trading the scalability with consistency. Because now there are multiple data stores, there is no apparent way actually, there is no easy way, let me say that, to make sure that all these data stores are updated at the same time or none of them are updated. There are certain patterns out there, like some people use Sagas to ensure consistency, and applications have to write in a lot of code for that, for orchestrate those services as well as write the compensating transactions. And this can be error prone. It requires a lot of testing, and it requires, of course, developers have to be really on the top of their game in order to make it work correctly. The testing complexity also increases. Now, because we are using the database, a separate database for each microservice, then it also complicates the data management. The other, like polyglot applications, microservices are generally developed in many different languages, Java, Node.js, and whatever developer feels comfortable, they can write microservices using that. And for consistency, generally you would use different framework. There is no common framework across these various languages. That's another challenge. So these are the challenges that we are planning to address in this transaction manager for microservices. So what is the Oracle strategy for this product? So our ultimate goal here is to reduce the cost for application development and time to market by reducing development effort that is required. Developers should not have to worry about all this consistency and provide these infrastructure level capabilities. Starting with, we are going to provide various levels of consistency across polyglot microservices. So as you would see, there are different transaction models that we want to adopt. And this is going to be an enterprise product. So we are going to focus on availability, scalability for the microservices, as well as we will try to optimize this product as much as we can for Oracle database, given that we are part of the Oracle database organization. So what this product is, I mentioned that we are going to provide a spectrum of consistency models across these services. For polyglot services, there are 3 models that we have chosen to begin with. We are going to provide XA and try, confirm, cancel for a strong consistency. And we are still going to support the Saga orchestration by supporting Eclipse microprofile long-running actions. This is going to be an enterprise product, as I mentioned before, so it's going to be highly available solution. We are going to make it, it's going to scale, so you should be able to do thousands of transactions per second in your architecture and so on. Security integration is going to be out of the box, monitoring, management, administration, all those capabilities will be available. Initially, we are planning to release this product for on-premise deployment. In future, we might provide this as a managed cloud service as well, or in hybrid mode. But even for on-premise, it can be deployed in cloud, in Kubernetes, and Kubernetes running in cloud and so on. The only thing, like, we are not providing the managed service for now. It's optimized for Oracle database. There are a number of XA optimization that we are planning to implement, and we are going to talk about those in a moment. POG is going to support various languages. It's a like polyglot service. That's one of our objective here. So Java, Node.js, C++ using Tuxedo. These would be supported in the initial release, and then in the future, we are planning to support Golang and Python. So what the product architecture looks like overall, all the yellow boxes here is something that this product would provide, and the green is the application. So the core of this product is going to be this transaction coordinator, which is going to support all these 3 transaction models, XA, LRA, and TCC. And then there's going to be a library for each of these transaction model that has to be linked with application. So TMMlib for Java, Node.js, Java, and for Tuxedo is going to be part of GWWS. That's the SALT gateway, the REST API gateway. One other thing that we are supporting in this is interaction or interoperability with the database resident services. So one should be able to call the database resident service like the PL/SQL stored procedure in the same XA global transaction as you are calling the Node.js or Java microservice. And then there is going to be a console that that would give the information about the transaction coordinator. And also on the right-hand side, you see various Kubernetes ecosystem components like the Jaeger and Prometheus and Grafana. So this product would be integrated with all those things as such. So you should be able to monitor transaction coordinator using Prometheus and Grafana, trace it using Jaeger, and the logging using EFK or ELK stack, and so on. And database, various database that we are going to support for XA, basically any database that support an XA in proper way that could be supported with TMM. For LRAs and TCC, any database can be used. So with that, let me turn it over to Todd, who is going to talk about the architecture and various features of Transaction Manager for microservices. Todd.
All right, thanks, Deepak. Appreciate it. So the first transaction model we're going to support are 2-phase commit transactions, which are often referred to as XA transactions based upon the XA standard. So in this case here, transactions are providing ACID capabilities. So that means the transactions are atomic, they have consistency, they're isolated, and they're durable. So ACID transactions are sort of the highest level of transaction consistency you can provide. So these are largely transparent to the application. So the application simply says, I want to start a distributed transaction, a 2-phase commit transaction. It does some interactions with the local resource manager. It calls other services to interact with other resource managers, such as databases. And all those then are coordinated as part of a single global transaction. So they either all commit or they all roll back. So it's been around quite a while. It's supported pretty much by every enterprise database, and it does provide the strongest level of consistent guarantees across distributed stores. So it's perceived as complex and not scalable. And I think those are issues that we're trying to address with this product. So from complexity, the complexity largely is handled by our service and our libraries. And as far as the scalable, it has to do a lot with application design. And there'll be a white paper that we present talking about how that can be addressed and how you can ensure that you get scalable distributed two-phase commit transactions. So for XA transactions, this basically is a mechanism to support, polyglot services using a variety of resource managers. And so we can support the ability to be able to have a single transaction that spans multiple services. So like in this picture here, we have a Node.js application, we have a Java application written in Helidon, and we have another application written using Django. So all these microservices are going to participate in a single two-phase commit transaction. So we will propagate the transaction context from one microservice to another microservice. So as each of these microservices communicate with each other, we will ensure that the transaction infection takes place, and so all of their manipulation of the database involved will be consistent. Some of the optimizations that we're trying to take place are things like one-phase commit. So if we can detect that all of the microservices are using a single transaction manager, we can do, or there's only one transaction manager that has not had a non-read-only prepare operation, we can do a one-phase commit against those. We're also looking at supporting promotable transactions. So this is a case where a transaction is local until such time as another resource manager becomes involved in the transaction. At that point, then we will promote the transaction to a global transaction and go through the two-phase commit protocol. Another optimization we're planning to support is what's called the logging last resource. This is an optimization of the logging resource optimization, last resource optimization. So in this case here, what we do is we allow one non-XA participant to be able to participate in a global XA transaction. And we do that by allowing the transaction manager to say, okay, this non-XA transaction becomes the determiner of the outcome of the transaction. So the transaction manager says, okay, when we're time to commit, we first prepare all the non-XA or all the XA transactions participants, and then we ask the non-XA transaction, the LLR transaction, to commit, and we store in that commit record the information about the status of the transaction for recovery purposes. So we get very good outcomes. We have very low probability of heuristics, but we can still include a single non-XA transaction or a resource manager in the transaction. We'll be setting a supported REST APIs that will handle the transaction management and management. And each of these will then be supported in the various languages. So we're initially supporting Java and Node.js, as well as Tuxedo and PL SQL in the database. We'll be supporting things like Go and other languages available in the future. We're also planning to support, popular frameworks for how do you develop REST applications. So our goal is to support pretty much any XA compliant resource manager, and as well as we'll have some additional optimizations that we'll be making for Oracle database. So one of the things we're providing as part of this library, and what we're doing to help simplify the application development, is we're providing interceptors. So interceptors in the JAX-RS environment, these are basically filters. So we allow the ability to intercept outgoing calls. We allow the ability to intercept the responses from those calls. We allow the ability to respond to and alter things like headers and the content for requests to a specific service. So if we look at this, we have a client here, makes a service call. We have interceptors here that we call inbound interceptors. Those can perform a variety of functions for us. They may propagate transaction context. They may allow us to do such things as calling back to perform operations such as on the local resource manager. So by using interceptors, we make most of this transparent to the Oracle app, the customer's application. One particular use case that we have for these interceptors is what we're calling the resource manager proxy. So in the normal case for two-phase commit transactions or with an XA transaction manager, the initiator calls the application code invokes the resource manager. The initiator also, though, invokes things on the transaction manager, and then the transaction manager communicates directly with the resource manager. The problems with this is that you have to have RM-specific libraries for each RM that you want to invoke. You have to have a connection to each of those RMs, and you have to have credentials for each of those RMs. So what we're implementing in the Oracle Transaction Manager for microservices is a proxy mechanism. And in this case here, the application itself provides a proxy to be able to access the resource manager. So the initiator simply calls the application code. When we go down to perform things like commit, rollback, those sort of transaction management functions, the application code with use of our interceptors enlists with the transaction. And so then the resource manager can be allowed to be accessed by the transaction manager without having all of these requirements to know about the transaction manager's specifics. So this gives us a way to be able to essentially support any resource manager given a library on the application participant side. So Sagas are another form of distributed transactions. These are very popular right now because of the presumptions that using things like two-phase commits and XA transactions have locking issues that prevent you from being able to use those kinds of features. We're not convinced that's the case, but there are obviously cases where Sagas make sense. So they're basically addressing the problem of loosely coupled transactions or services that over time eventually become consistent. So initially they may be consistent, they may go through a set of states where they're inconsistent. So some users may see some information, other users may see other information. The whole idea is that at the end, either all the updates either occur or all of them get rolled back and compensated. So it's similar to a two-phase model, but the compensating transactions or compensating actions are completely up to the application. So what happens is you have each of these services that are involved in a Saga. They all are committing local transactions. And what has to happen is that if some of those transactions can't commit, then the other ones have to be able to perform some sort of compensating action to be able to make sure things remain consistent. So it's a bit more complex for the application, but it is a model that we're supporting with the OTMM. So in the case of for the Saga applications, what happens is that when a service is involved and it starts a Saga, it basically tells the transaction coordinator, our transaction coordinator that's beginning the Saga, when that calls to other transaction services, we propagate that information. They enlist in that Saga so they're aware of whether the Saga is completed or it needs to be compensated. And that happens across a variety of different microservices. So we're supporting this using annotations in Java, and eventually we'll be supporting that in TypeScript. As well as we'll be looking at being able to provide automated compensating transactions or capabilities based upon things like the escrow columns that are coming up in the Oracle database next release. So the third model we're supporting is we're calling the try, confirm, cancel model. So this is another model. It's similar to the two-phase commit model. The difference is that things aren't locked, but instead what happens is that things are placed in reservation. So it requires a reservation model. So this might be book a hotel flight, book a hotel room, and book a rental car. And so if all those happen, that's part of the try phase, then the initiator would say, okay, I like all those reservations, confirm them, at which point then all those pending transactions, if you will, the things that were placed in reservation are now made current. And should the initiator say, oh, no, I don't want those transactions, simply cancel those, at which point then the transaction coordinator would tell all the participants to cancel the reservations that were made. So this is a very capable model, but it does require this notion that things are placed in a reservation mode, and that the transaction coordinator can either confirm those reservations or cancel those reservations. And this is all done through HTTP verbs, so it's a pretty common model. So as I mentioned here, so in the case of you have a number of different services here. The services, when they're called, each one so if we have service A on the left here, and it calls another service, then we'll propagate the transaction context. We'll have that other service enlist itself in the transaction, notifying the transaction coordinator that it wants to be aware of whether they should confirm or cancel the transaction, and same likewise for any other services that are involved. So this is basically a orchestration mechanism. So the coordinator here is orchestrating the confirm or the cancel of all the participants in the transaction. We're also planning to support in our first release here for the ability to be able to support Oracle database, what we call Oracle database resident applications. So these are PL SQL procedures that are typically made accessible via ORDS, the Oracle REST Data Services. And as well, then Apex provides the ability to be able to make outgoing REST calls to other transaction services or other microservices. So we will support PL SQL-based, ORDS-based applications in the same way we support them for Java and for TypeScript, such that an ORDS application can invoke other microservices. Those microservices can participate as part of a global transaction, and we will coordinate all of that. So likewise, we'll be looking to support this for Sagas and for other models as well, but initially what we're supporting is going to be XA and the try, confirm, cancel. Finally, one of the things we're planning to support here is because the team here comes from the Oracle Tuxedo team. So we are planning to support Oracle Tuxedo applications as part of a microservice global transaction. So the model here is basically that in Tuxedo, everything's a service. So it already supports this sort of microservice model. Tuxedo is extremely low latency. We tested practically a decade ago transaction invocations taking about under 30 microseconds for request response pair. It's truly very scalable. The TPCC benchmarks, the highest ones ever recorded, were using Oracle database and Tuxedo and exceeded 500,000 transactions per second. It's used for things like rehosting mainframe applications because we have a strong correlation between things like CICS and IMS based on what Tuxedo can provide. We have a number of different gateways to be able to talk to different services and different environments. And it's a very widely used product. And so every Walgreens store and every PeopleSoft installation, every Swift gateway, all those things are all based upon Oracle Tuxedo. So one of the things we've been providing as part of the Oracle Transaction Manager for microservices is the ability to have Tuxedo services participate in these distributed transactions. In the first flavor of this, we will only have Tuxedo be able to be a participant. It won't be able to be initiating a global transaction. So another microservice would start the global transaction. It may call Tuxedo's microservice through the Salt Web Services Gateway, and then that particular Tuxedo transaction then would become part of the overall global transaction. So we get guaranteed, asset properties across a variety of microservices and across a variety of Tuxedo applications.
Yeah, thanks, Todd. Yeah, the next item is the demo for this transaction manager to see this functionality in action. So let me just set the stage here for the demo, and then I'll hand it over to Brijesh for the demo itself. As we have discussed that we are going to provide, we are going to show you application written in Node.js and Java. Here the client application is initiating the transaction is written in Node.js, and then there are two participant microservices. Both are written in Java. One is running in Helidon framework, another running in Spring framework. So here the client written in Node.js initiate the transaction. It calls the Helidon service to withdraw money, and then the Spring service to deposit it. So with that, let me hand it over to Brijesh. I'll stop sharing, and then Brijesh, you can share.
Thanks, Deepak. I'll start sharing now. In this demo, I'm going to show how our TMM offering can be used to build a solution that uses XA transaction. So for this demo, let's assume there is an accounts department in a large organization. that is responsible for transferring amounts between different departments by creating an exit transaction. And for that, it uses the transaction coordinator. And within the exit transaction, all the asset properties of a transaction are honored. So all the actions, whether the withdraw or deposit, will either completely succeed or be rolled back. So that is what we're going to see in this demo. And the TMM offering has two main components, that is the transaction coordinator and the TMM library. The transaction coordinator maintains the state of the distributed transaction by coordinating the transaction events between the different participants. And the TMM library provides the means for communication between the transaction participants and the transaction coordinator through REST APIs. And a participating service or an application in this exit transaction must include the TMM library in its implementation. So that is a requirement here. Having said that, so these are the three participants that you see here, the accounts department, and then we have the department 1 and department 2. And like the screen that Deepak showed earlier, so this accounts department has been implemented using Node.js, and department 1 is based on Helidon framework, and department 2 is based on the Spring framework. This is the transaction coordinator. So now I'm going to transfer some amount from department 1 to department 2. And for that, the accounts department would be initiating the exit transaction. So let's see the demo now. Yeah. So before that, let's check the balances in the accounts for the department 1. You see here, we have the department 1, and then this 111 is the account in department 1 from which we are going to transfer some amount to another account in department 2. So before doing that, let's check the balance for account 111 in department 1. So you see here the account ID is 111. The amount that the balance is 660 is the amount that is with account 111. Similarly, let's check the balance in department 2. So in department 2, we are going to transfer the amount into account number 222. So let's see the balance there right now. So the balance is 2375. So now I'm going to initiate a transfer. So you see here, this is how the payload looks. I'm going to call transfer, and then from account 111 into account 222, an amount of 10 would get transferred. So let me run this. So the transfer is completed. We can check the balance again and make sure the transaction has gone correctly. So let's check the balance in department 1. So the account's ID with 111, the balance has changed to 650 from 660 earlier. So there was a withdrawal of 10 from this account. And then let's check the balance in department 2. So here you see the balance has increased from 2375 to 2385, and an increase of 10. So there was a deposit of 10 here. So this is how the transaction looks like. And then we can see that in the Scali dashboard here. So I'm going to explain the events that have taken place here. So this is how the so the request came in through the ingress gateway here, and then when we send the command, got into the accounts department through the ingress gateway, and from the accounts department, request for withdrawal was made to the department 1, and upon getting the request, the TMM library inside the department 1 enlisted this department 1 with the transaction coordinator by making an enlist call here. Similarly, a deposit request was sent from accounts department to the department 2, and then the TMM library enlisted department 2 with the transaction coordinator. Then once both withdrawal and deposit were successful, then the accounts department sent a commit request to the transaction coordinator, and then the transaction coordinator made a prepare and commit calls into department 1 and department 2 to commit the transactions on both these departments, and that overall that basically completed this transaction. So this is how the transaction, a successful transaction looks like. And then you can see here there is this pass-through cluster. Both department 1 and department 2 are using separate instances of an ATP database. So that is the Oracle ATP database. And so this is what it shows here. This is the connection that is being shown from department 2 into the database, which is not within this cluster. So the database is an ATP instance which is running in OCI, Oracle Cloud. And here what we are seeing is all these the services that are deployed within this service mesh in the Kubernetes cluster. So now we saw how a successful transaction looks like. So I would also like to show you a rollback use case here. So now you see here, we'll try to, so for the rollback, we'll try to deposit some amount into an account that does not exist. So we saw here the department 2 has 222 as the valid account. So let's see another account here. Let's say 666. So 666 is not a valid account. So basically, this account does not exist. So that's why you see this error here. Yeah. So this HTTP, you can see the 404. This account was not found. So then we'll try to deposit into this account, and then see what happens here. So now I'm trying to deposit it into a non-existent account. Yeah. So there was a deposit exception that you see. So the deposit failed, and then the transaction got rolled back. And that we can so the balances should not have changed in the case of department 1 and in the case of department 1 here, because department 2 is anyways non-existent account. So you see here the balance has not changed. The balance is still 650, and this can be visualized again on the carry dashboard. So you see here, we made a withdraw call from the accounts department to department 1. So the withdrawal was successful, but the deposit call made to department 2 failed because the account was non-existent in department 2, and that triggered the failure from here. So the department 2 fails by the accounts department called a rollback on the TMM coordinator here, which the transaction coordinator then called the rollback on department 1, and then what had happened got rolled back, and then the balance did not change in department 1 as well. So this is how it looks in the case of a rollback transaction, which failed because of either the withdrawal failed or the deposit failed, and then the point of failure or the path of failure is also visible here in red that you see. Yeah, so this is all that I have for the demo.
Okay, thanks a lot, Vijesh. The next item is the roadmap and upcoming features. So this is just to tell you where we are in the product lifecycle. We released a beta version of the product in February of this year. This number of participants, customers, and partners are working with the product already. And here is the list of features that we have released in the beta version. So we support all 3 transaction models in this beta. We support Java, Node.js, C++ via Tuxedo, and PLSQL via Oracle database. So application services can be written in any of these languages. The product is deployed in the Kubernetes environment along with a service mesh. And service mesh that we support here is Istio and Envoy-based service mesh. So that's a prerequisite for the product deployment. Full lifecycle management is using the Helm chart in the beta version. It's fully integrated with the Kubernetes ecosystem, so the Prometheus, Grafana, ELK, FK, and so on. All those components can be used to monitor the product as well as the transactions. Services can be deployed across multiple Kubernetes clusters. You can have all the services in the same cluster as well as across different clusters as well. We support OpenID, JWT-based authentication and authorization for secure deployment. Some of the environments that we support are OKE as well as Minikube and OKD, which is the development environment for OpenShift. As far as the RM for XA support is concerned, we support Oracle database and MySQL. We are working on others for the GA release. For identity provider, we support Microsoft AD and identity domains in Oracle Cloud if you are using OKE in Oracle Cloud, and Keycloak, which is an open source identity provider that is supported as well. The beta version also includes a couple of quick start guide to start with OKE. That's the OCI Kubernetes engine and the Minikube in Minikube environment. So there are sample applications that can be used to deploy in these environments using the quick start guide. So these are the features that are released in the beta version, and then the GA version that we are targeting for July this year. There are a number of usability enhancements that we are planning in this release. Last logging resource is one of them. Todd described that in detail, what that is. Then other also application development related enhancement, XA data source. When you're developing the Java XA microservice, so make it easier to develop that. Nested transaction. So within an LRA, you should be able to have an XA embedded, nested rather, XA transaction nested. And the performance enhancement, the common XID, so we don't have to do two-phase commit. We can just do one-phase commit if all the participant microservices are talking to the same RM. So that's one of the optimization with Oracle database, as well as others. And then TMM console, that's going to be part of the GA release. We are going to certify the Oracle Linux container native environment in GA release, and maybe some other Kubernetes environment like VMware, Tanzu, so on. And we are also exploring possibility of including TMM as part of the Verrazano enterprise container platform that was released last year. So these are some of the features which we are targeting for the GA release, and then beyond GA also we have a number of things in the pipeline. So we are already started working on this Kubernetes operator for TMM, and then support for other programming languages like Python and Golang. Then provide the TMM as a service in OCI. So this is going to be a managed service in Oracle Cloud. Tuxedo, we support interoperability for inbound. So when we are calling into Tuxedo and invoking a service within an XA transaction, that is supported, that will be supported as part of GA. But for outbound, if someone initiates a transaction from Tuxedo service and invokes Node.js or Java or other languages, microservices, so that's the outbound support. Integration, simplified integration. So there are certain code that one has to write in order to integrate with database resident service. We want to simplify it further. And then LRA support. Right now we support only XA for interoperability with database resident microservices. We want to support LRA as well. So these are the features that we are looking at beyond GA, beyond the first release of the product. So that is pretty much it. If you have any question, we can take that, and you can also reach out to the Oracle team and so on.